Introducing the Ruminant Farm Systems model, RuFaS. RuFaS represents a cutting-edge approach to integrating and synthesizing dairy research, employing modern modular coding and development practices to build a flexible, adaptable, and interoperable open-source whole farm modeling environment to simulate sustainable milk production. To understand RuFaS, first we have to ask, what is a model? To put it simply, a model is a representation of something. Most people interact with models on a regular basis, whether it's an app on your phone that uses a model of the streets around you for navigation, or a model of the weather that lets you know when it's likely to rain. In agricultural research, models allow farmers to run scenarios to explore the effects of different feed formulations, changing crop rotations, or the implementation of new manure management strategies. That's where RuFaS comes in.
Our vision for RuFaS extends beyond academia. We see RuFaS as being used by both scientists and industry partners to understand how farm management affects production and environmental outcomes. Our goal in the RuFaS project is not just to build the most accurate dairy farm simulation model that we can, but also to build the most transparent and accessible model that we can. In doing this, we believe that we can provide a platform for scientific collaboration that enables model users to integrate information across disciplines and across parts of the farm in ways that can only be achieved with digital tools. And by continuing to update RuFaS with new technologies and scientific discoveries as they arise, we can quickly translate innovations into practical applications on farms by combining new insights with existing knowledge that can enhance farm management and environmental sustainability.
Let's look at how RuFaS is built. The foundation of RuFaS is 4 interconnected biophysical modules: animal, manure, soil and crop, feed storage. These process-based modules simulate production, nutrient flows, transformations, and losses on a single farm, updating predictions and passing information between the modules on a daily time step. The animal module is in charge of simulating individual animals' daily activities within the herd throughout their life cycle. Along with modeling herd performance, this module also simulates ration formulation, generating estimates of feed consumption, manure excretion, and enteric methane. Excreted manure is then passed to the manure module each day for simulation of manure collection, processing and separation, anaerobic digestion where applicable, and storage. From this, RuFaS can simulate changes in manure quantity and composition, as well as emissions related to storage and the impacts of anaerobic digestion. The soil and crop module simulates the daily changes in soil composition and crop growth. This module can receive manure from the manure module for application in the fields, in addition to or as a replacement for chemical fertilizer application. Users can tailor crop rotations, nutrient applications, and tillage practices to simulate crop growth, runoff, leaching, emissions, soil carbon changes, and other field outcomes in conditions that closely match those on their farm. Harvested crops are transferred to the feed module for storage, along with all purchased feed ingredients and additives. Users can define a ration or allow RuFaS to formulate a ration based on nutrient requirement models for each animal class. RuFaS will then simulate dry matter intake by feed ingredient and animal class, as well as summarize embedded emissions in any purchased feed. The information generated by the biophysical modules is collected into the output manager, which then can either be reported or used to inform additional estimates of farm energy use and economics. So, how are all these modules brought together in the RuFaS code?
The RuFaS code is crafted using best practices in software engineering, what we call solid principles, which help keep the code simple, easy to read, well organized, well documented, easy to modify and test. We have designed it to be modular, so if science evolves or we need to add new features, we can simply bring it in without disturbing the entire code. This makes RuFaS not only maintainable and scalable, but highly flexible and ready to adapt to the future needs of its users.
When you put all this together, RuFaS is a one-of-a-kind, unique model. It is process-based, meaning that a dairy farm is represented as interacting components. This interconnectivity allows users to explore different management strategies and see how their effects ripple out across an entire farm. Herds modeled in RuFaS are detailed all the way down to the level of individual animals and include randomness, so it's not modeling the average cow. These digital cows express variation as they grow on a daily basis, resulting in individualized requirements and milk production. Rufus is backed by scientific documentation to make the model transparent and to actively encourage participation in the model's ongoing refinement and further development. And Rufus is already being used throughout the dairy community. The farm program has integrated Rufus into its environmental stewardship program. This allows farm users to leverage the power of Rufus to understand their current production and sustainability footprints. Farmers can also simulate the outcomes of different farm management decisions, providing more insight as to how those changes could affect their operation. As part of our commitment to shorten the path from scientific innovation to application and transparency, Rufus is now open source, meaning the code itself is freely available for use and review. So come join us and see how Rufus can complement your science program and enhance your on-farm decision-making.